Hello, welcome to the video. Today we will discuss something important, which is about the computer science. This topic is about computer science, about microcontrollers, microprocessor, electronics, electrical engineering, control engineering, lot of. So let's see what is assembly language or low level language. People call it low level language and high level language. So we will talk normally about this thing. So how things are going on here. So basically, if you talk about assembly language or high level language, let's say first talk about assembly language, why it is important and why do we need assembly language, why do we need high level language. So in terms of assembly language, if we talk about how assembly language is made, so let's take a simple example of a statement or instruction in assembly language. Let's say this is the simple instruction of 8085, let's say move A comma B. So how assembly language is converted? So let's say for this move we have decided that we will take move as 0 1 in binary, and we have taken the accumulator register as 1 1 1 in binary, okay, and we will take this B register as 0 0 0 in binary. Let's say we have decided as a designer to take the text in form of binary like this. So whenever we type move, we will take 0 1. Whenever we type A, we will take 1 1 1. Whenever we type B, we will take 0 0 0. So now if you see, you have an 8-bit binary pattern, right? So this 8-bit binary pattern will need 8-bit memory cells to get saved, or we can also say it will need 1 byte memory to get saved, because 8-bit is 1 byte. So that's how your 1 byte instruction is formed. You see? So this is the basic concept of 1 byte instruction. Or if you want to understand the hex code, what is hex code for this pattern? So if you make pairs of 4, so 1 2 3 4 and 1 2 3 4, so this is your hex code. So you can represent this number in binary. If you want to represent this in hexadecimal, so you see this is 7 and this 4 is 8. So this is 78H. So now you can write your move A comma B as 78H, and then this will get converted into binary. So this is the basic idea of how your hex code is developed, or after hex code how your binary is developed. So when you see about memory, so always remember the basic idea of a memory is it will always have 8 cells. 8 cells. Now this move A comma B instruction will get saved here like this, right? So let's say this is an instruction 78H which gets saved in memory like this. So it has taken one memory, so that's why it is called 1 byte instruction or 8-bit instruction. Now, if you have an instruction like this, so let's say if you have an instruction like MVI A, let's say 35H, right? In terms of microcontroller, if you see, you have an instruction like move A, hash 35H. Some instructions like this. So in these type of instruction, you see, you have a number written here. So to represent this hexadecimal number, you need a 8-bit pattern of binary. Forget this thing right now. Just remember, to represent this number, you will need an 8-bit binary pattern. So to write 35, you have to write 0, 0, 1, 1, and 5 will be written as 0 and 1, 0, 1. So this is the 8-bit pattern for 35, and you haven't written this thing right now. So first this will get saved here 0, 0, 1, 1 and 0, 1, 0, 1. So this will get saved first, this 35, and then in the next memory the binary code for MVI A or move A will get saved. Now, if you can represent MVI A or move A just by 3 digits, 111, 111. So you take 111 here, let's say. Still, you have to fill these 5 boxes. You cannot leave them, these 5 boxes. So that's why you need 2 memory cells. So this instruction will become 2-byte instruction. So you will need at least 5 bits for them. So this is 2-byte instruction. Similarly, whenever you write any program or any instruction like LXI or LDA 2500, right? Load the accumulator from this memory address, or you write something like move, right, for microcontroller A, 2000H, something like that, right? So here you see, now this will take 16-bit to represent. Similarly, this will take 16-bit to represent. So 16-bit means it will take at least 1 and 2 memory locations. Just this number, it will take 2-bit memory location. Okay? So when you represent LDA also, it will take 3 memory locations. So that's how 3-byte instructions are formed. So this whole is what is going on in assembly. So you make the instruction and then you have a hex code for it, and then assembler will convert that hex code to binary and it will get saved into memory. So that's what is happening here. So we'll see what is happening here in assembly. So you have a instruction or program, right, or program. That program you give, so that program will have a hex code, right? All the instruction will have a hex code, and when you give this hex code to assembler, it will gets converted to binary, and this binary will go and get saved into the memory room of the microprocessor or microcontroller. So this is what is happening in assembly language, or what you say as low level language. So what is the problem then? The problem is this assembly code, whatever you have written here, so someone or the developer has decided that it will have some hex code, right? So this is, because this is decided by the developer, so this becomes a device dependent thing. Device dependent means if you write a program, like you write MBI command, right? MBI A, 35H. Let's say I have not given any hex code to this text MBI in my microcontroller. So now you cannot run this program. So that's the main problem of assembly language, that it is device dependent. So for every company's microcontroller, you will have to learn its assembly language. So like for Intel microcontroller, you will have a assembly language. For Motorola's microcontroller, you will have another assembly language. So you have to read lot of assembly languages. So now when you go to high level like C, what C does is it is device independent. That's one of the advantages of high level language. So if we talk about high level language, so what high level language is doing, so what high level language is doing, like C, so you write a program in high level language, right? So let's say you write whatever you write in C, like hash include, void main, etc, etc, etc. So now you will give this program to your compiler. So what compiler will do now, compiler will make it device independent. So compiler, but again compiler will convert it to assembly code or hex code, you say. Compiler will again convert it to hex code. Now this hex code will get converted again to binary, and this binary will go and get saved into the ROM. So this is basically the whole idea of your high level language, that you will write a program which is called compiler, which has all the set of rules for converting this code into assembly code. So in C, you have a GCC compiler which is doing this thing, right? So it is compiler who is making this whole code device independent. So that's why high level languages became popular and more in use. Also they have so many other advantages, also like library, they have so many libraries, and it is very easy to implement complex logic in the high level language, where in assembly language it becomes more tedious. So but this is the main advantage by which high level language are developed. So many people also say C is also low level language. That is also a part of discussion, but that's how the things work. Okay, so high level language, compiler convert it, and then compiler will convert it to the particular device's assembly code, and from there assembler will convert it to our hex code. So, and there is one more thing, when compiler will convert the C language to hex code, it generally make a bigger file than a normal programmer will make for assembly hex code. So when compiler will make hex code, the size will be much bigger because you have set of rules by which compiler is converting. But when programmer will make assembly code, obviously the size will be less. But still you choose high level language because sometimes some tasks are very tedious in assembly language. Okay, so thank you very much, and please like and subscribe. We'll see you for some other interesting discussions